Hello students, I am Dayana, Assistant Professor EEE Department, ARUNACHALA College of Engineering for Women. In this video, we are going to see the introduction to electromagnetic fields and vector fields. Introduction. The field is a function that specifies a quantity everywhere in a region or a space. If at each point of a region or space there is a corresponding value of some physical function, then the region is called a field. If the field produced is due to the magnetic effects, it is called magnetic field. There are two types of electric charges. One is positive and another one is negative charge. Such an electric charge produces a field around it, which is called an electric field. Next, electromagnetics. What is meant by electromagnetic field or electromagnetics? Electromagnetics is a study of interaction between electric charges at rest and in motion. Moving charges produces a current and current carrying conductor produces a magnetic field. In such a case, electric and magnetic fields are related to each other. Such a field is called as electromagnetic field. Electromagnetic devices. The examples of electromagnetic devices are transformers, telephone, electric relays, radio, TV, electric motors, transmission lines, waveguides, antenna, optical fibers, radars and lasers, etc. The sources of electromagnetic fields. The sources of electromagnetic fields are sound intensity in an auditorium, light intensity in a room, atmospheric pressure in a given region, gravitational force on a mass in a space, velocity of particles in a moving field, wind velocity of atmosphere, voltage gradient in a cable. Next, we will see about the vector fields topic. Okay, what is scalar and what is vector? Scalar is a quantity which is wholly characterized by its magnitude. The examples of scalar are temperature, mass, volume, density, speed, electric charge, etc. The vector quantity which is characterized by both magnitude and direction. The examples of vector quantity are force, velocity, displacement, electric field intensity, magnetic field intensity, acceleration, etc. Scalar field and vector field. First, what is scalar field? The distribution of a scalar quantity with a definite position in a space is called scalar field. The examples of scalar field are temperature of atmosphere, height of surface of earth above sea level, sound intensity in an auditorium, light intensity in a room, atmospheric pressure in a given region, etc. Next, what is meant by vector field? If a quantity which is specified in a region to define a field is a vector, then the corresponding field is called a vector field. The examples of vector field are gravitational force on a mass in a space, velocity of particles in a moving field, wind velocity of atmosphere, voltage gradient in a cable, displacement of flying bird in a space, magnetic field existing from north to south field, etc. Representation of a vector. In a two dimensions, a vector can be represented by a straight line with an arrow in a plane. The length is equal to the magnitude of the vector. The arrow indicates the direction of the vector. Here the figure shows the vector OA vector. Here O is the starting point of the vector, A is the terminating point of the vector. And the magnitude of the vector is equal to the magnitude of vector R is equal to the modulus of OA vector. Unit vector. The magnitude of the unit vector is unity and has the function to indicate the direction. The unit vector can be obtained by dividing the vector by its magnitude. So unit vector is equal to the OA vector is a OA vector. So the unit vector of OA vector, small a suffix OA vector is equal to the vector divided by its magnitude. Here the vector is a OA vector. So OA vector divided by its magnitude of OA vector. Scaling of vector. It is a multiplication by a scalar to a vector. That multiplication changes the magnitude of the vector but not its direction when the scalar is positive. Here alpha is a scalar with which vector is to be multiplied. So here there are three cases. When alpha is greater than 1, the magnitude of the vector increases but the direction remains same. Second case, if alpha is less than 1, the magnitude of the vector decreases but the direction remains same. When alpha is equal to -1, the magnitude remains the same but the direction of the vector reverses. Addition of two vectors. So how to add the two vectors? So consider two vectors, A vector and B vector. So we have to add the two vectors. So the resultant vector, sum of these two vectors, C vector is equal to A vector plus B vector. C vector is the sum of two vectors or the resultant vectors. So consider the figure. This is the A vector and this is the B vector. We have to add these two vectors. Okay. Here we have to move the A vector to the tip of the B vector. Okay, to add the two vectors, we have to move the A vector to the tip of the B vector. So this is a B vector and we have moved the A vector to the tip of the B vector. So now add the two vectors, B vector plus A vector gives a resultant vector C vector. So C vector is equal to A vector plus B vector. Another method of performing the addition of vector is by using the parallelogram rule. So here complete the parallelogram. The diagonal of the parallelogram represents the resultant vector or addition of two vectors. Okay, the another one method is by using the parallelogram rule. So this is the A vector and this is B vector. So complete the parallelogram. The diagonal represents the resultant vector or a sum of two vectors. Addition of four vectors. So consider four vectors, A vector, B vector, C vector and D vector. Here we can use the first method. Okay, so first consider the A vector. Next move the B vector to the tip of the A vector. Next move the C vector to the tip of the B vector. Next move the D vector to the tip of the C vector. Now the resultant vector is equal to the sum of A vector plus B vector plus C vector plus D vector. Basic laws of algebra. So the first law is commutative law. For addition, A vector plus B vector is equal to B vector plus A vector. In multiplication by a scalar, alpha into A vector is equal to A vector into alpha. The second one is associative law. A vector plus B vector plus C vector is equal to A vector plus B vector plus C vector. Multiplication by a scalar. So beta is here, beta is a scalar. So beta into alpha A vector is equal to beta alpha into A vector. Third one is a distributive law. Alpha into A vector plus B vector is equal to alpha A vector plus alpha B vector. Multiplication alpha plus beta into A vector is equal to alpha A vector plus beta A vector. Subtraction of two vectors. So how to subtract two vectors? So consider two vectors, A vector and B vector. So we have to find A vector minus B vector. The answer is the resultant vector is a C vector. To subtract the two vectors, we have to reverse the sign of B vector. That is, reverse the direction by multiplying it with -1 and then add it to A vector to obtain subtraction. Okay, so here A vector and this is B vector. So we have to find A vector minus B vector. So this is A vector and this is a B vector. So A vector, we have to multiply -1 with B vector. So we'll get minus B vector. Now add A vector and minus B vector by using parallelogram rule. So the result diagonal gives a resultant C vector. C vector is A vector minus B vector. Base vectors and position vector. So first we will see about the base vector. Base vectors are the unit vectors which are strictly oriented along the direction of the coordinate axis of the given coordinate system. So next one is a position vector or radius vector. So position vector or radius vector is the distance directed from the origin to the point P. Okay, the position vector is equal to OP vector, that is equal to P vector minus O vector. O vector means it is origin. So simply it is equal to P vector. OP vector is equal to, generally the OP vector is equal to P vector. Distance vector or separation vector. Distance vector or separation vector is the displacement from one point to another point. Here consider 2 points P of x1, y1, z1 and Q of x2, y2, z2. Simply we will say this is a P vector with x1 ax vector plus y1 ay vector plus z1 az vector, and this is Q vector. This is the coordinates of the Q vector. Q vector is equal to x to ax vector plus y to ay vector plus z to az vector. The distance vector PQ vector is equal to Q vector minus P vector. That means it starts from P point and ends at Q point. Okay, P is the starting point, Q is the terminating point. So distance vector is normally equal to terminating point minus the starting point. Here Q vector, PQ vector is equal to, here P, consider the PQ vector. P is the starting point and Q is the terminating point. So that is equal to terminating point minus the starting point. So Q vector minus P vector. The coordinates of Q vectors are x2, y2, z2 minus coordinates of P vector is x1, y1, z1. We can write P vector is equal to x1 ax vector plus y1 ay vector plus z1 az vector. Q vector is equal to x2 ax vector plus y2 ay vector plus z2 az vector. So distance vector PQ vector is equal to Q vector minus P vector. So we have to subtract the coordinates of the Q and P. So x2 minus x1 into x vector plus y2 minus y1 into ay vector plus z2 minus z1 into az vector. Here ax vector, ay vector, az vectors are the unit vectors along x, y, z axis direction. Product of vectors. When two vectors are multiplied, the resultant is either scalar or vector. There are two types of vector multiplication. One is scalar or dot product. Second one is vector or cross product. Scalar or dot product. The scalar or dot product of two vectors, A vectors and B vector, is denoted as A vector dot B vector. The scalar product or vector product is denoted as A vector dot B vector. So consider two vectors, A vector dot B vector. The scalar product of two vectors, A vector and B vector, is denoted as A vector dot B vector. It is defined as the product of magnitudes of A vector and magnitude of B vector and cosine of smaller angle between them. So from the definition we can write the formula A vector dot B vector is equal to magnitude of A vector, magnitude of B vector, cos theta AB. Theta AB is the angle between A vector and B vector. The result of dot product is a scalar. So the answer is a properties of dot product. If two vectors are, first property, if two vectors are parallel to each other, then angle theta is equal to 0. So cos 0 is equal to 1. So from the formula apply, cos theta is equal to 1. So A vector dot B vector is equal to magnitude of A vector, magnitude of B vector into cos theta. So here theta is equal to 1, cos theta is equal to 1. So that is equal to A vector dot B vector is equal to magnitude of A, magnitude of B for parallel vectors. Second one is if the two vectors are perpendicular to each other, then theta is equal to 90 degree. Consider two vectors, A vector and B vector. The two vectors are perpendicular, so theta is equal to 90 degree. Cos 90 is equal to 0. So A vector dot B vector is equal to magnitude of A, magnitude of B into cos theta. Here theta is equal to cos theta is equal to 0. So A vector dot B vector is equal to 0 for perpendicular vectors. So second property may be used for the problem to check whether two vectors are perpendicular or not. Third one is dot product obeys a commutative law. A vector dot b vector is equal to b vector dot a vector. Dot product obeys a distributive law. So a vector dot b vector plus c vector is equal to a vector dot b vector plus a vector dot c vector. Third one is a vector dot a vector is equal to magnitude of a into angle between a and a is 0. So cos 0 1. So we'll get magnitude of a square. Sixth one is dot product of different unit vectors is 0. Ax dot ay is equal to ay dot ax equal to 0 because the angle between x-axis and y-axis is equal to 90 degree, cos 90 is equal to 0. So these are the two perpendicular vectors. These two are the perpendicular vectors, so we will get 0. Seventh one is ax dot ax vector equal to ay vector dot ay vector is equal to az vector dot az vector is equal to 1. The angle between x and x-axis is 0. So cos 0 is equal to 1. So we will get the answer 1. So magnitude of unit vector. Small a represents a unit vector. Magnitude of unit vector is equal to 1. So 1 into 1 into 1, 1. So from the dot product, theta AB is equal to cos inverse of a vector dot b vector divided by magnitude of a vector into magnitude of b vector. Vector product or cross product. So vector product is denoted as a vector cross b vector, and it's defined as the product of magnitudes of a vector and b vector and the sign of smaller angle between them. So from the definition we can write the equation a vector cross vector product is a cross product. A vector cross b vector is equal to magnitude of a vector magnitude of b vector sine theta ab into an vector. So an vector or an cap, it is a unit vector perpendicular to the plane containing a vector and b vector, or unit vector normal to the plane containing a vector and b vector. So properties of vector product. So first property is a vector cross b vector is equal to b vector cross a vector. So commutative law is not applicable. Second one is a vector cross b vector cross a vector is equal to minus of a vector cross b vector. Third one is the cross product is not associative. So a vector cross b vector cross c vector is not equal to a vector cross b vector cross c vector. Fourth one is the cross product is distributive. That is a vector cross b vector plus c vector is equal to a vector cross b vector plus a vector cross c vector. Fifth one is if two vectors are parallel to each other, then the angle is 0 degree. So theta is equal to 0 degree. Sine 0 is 0. So a vector cross b vector is equal to 0. Sixth one is a vector cross a vector. The angle between two same vector. So angle theta is equal to 0. So sine 0, 0. So we'll get the answer 0. Seventh one is ax vector cross ay vector. Two perpendicular vectors. So the angle is 90 degrees. So ax vector, magnitude of ax vector, magnitude of ay vector, sine 90 degree into an cap. Sine 90 is 1, magnitude of x vector, magnitude of ay vector is equal to 1 because magnitude of unit vector is equal to 1. So we'll get the answer an vector or an cap. Okay, the perpendicular vector, that is answer is equal to az vector. So, because the z axis, the z vector is perpendicular to both x and y vector. Okay. We have studied the Cartesian coordinate systems. X, Y, Z are mutually perpendicular to each other. The Z axis is perpendicular to X and Y, and X axis is perpendicular to Y and Z. That concept is applied here. So X vector is equal to AY vector, that is equal to sine 90 degree, that is equal to 1. X vector cross AY vector is equal to AZ vector. Okay, from this equation. Similarly, AY cross X equal to minus AZ vector, and AY cross AZ is equal to AX vector. So AZ cross AY is equal to minus AX vector. AZ cross AX vector is equal to AY vector. So AX vector cross AZ vector is equal to minus AY vector. The last property is x vector cross ax vector equal to ay vector cross ay vector equal to az vector cross az vector is equal to 0 because the angle between x-axis and x-axis is 0. Sine 0 is equal to 0. So the answer is 0. And also you have to study the an vector formula and sine theta ab formula. Thank you.